In this lesson, we're going to take a look at naming polyatomic ionic compounds and also coming up with their formula from their names. So polyatomic ions, the word poly just means many. So we looked in binary ionic compounds at monoatomic, so made up of one type of element. Polyatomic ions are going to be made up of two or more types of atoms that are connected through covalent bonds, but then they will work together as an ion. So that group will either gain or lose electrons from something else, and it will as a group act as one ion. So there's going to be an overall charge on that group. So a metal and a polyatomic ion will give us an ionic compound. And we can find the polyatomic ions and their formula and the charge they have on them, as well as the name associated with them in our My Best Friends data sheet. So for example, acetate is C2H3O2 and it's got a charge of 1-. So unfortunately the minuses are quite small on here, but you can always zoom in and out here. Ammonium, NH4+. So 1 nitrogen atom, 4 hydrogen atoms, and as a unit, they have a positive charge, which means overall 1 electron has been lost from that group. Okay, so we'll take a look at positive polyatomic ions. And they get treated like metals. So ammonium, and that was one of the ones we looked at, is one of those. So ammonium, when we look it up, is NH4+. So to come up with the formula that ammonium chloride would have, we follow the same steps as before. So of NH4+, chlorine is a Cl-, so we can put our numbers in. We will crisscross our numbers and then do lowest terms, which here we have 1 and 1, so we can't go any lower. And we also won't write the 1. So here we have NH4 and Cl is the formula for ammonium chloride. And I'm going to do another one here, ammonium sulfide. So if you want to pause the video here and try this one on your own, that would be a good idea. So ammonium, once again, is NH4, has a 1+ charge. Sulfur is in group 6, so it has a 2- charge. And as I do my crisscross, there's once again no lowest terms here. However, I now have 2 NH4s, 2 ammoniums. If I were to write that like this, that would look like 1 nitrogen and 42 hydrogens, which is incorrect. So we don't want to write that. So the way to show that we have 2 ammoniums, which each ammonium works together, so 1 nitrogen and 4 hydrogens as a group, and we have 2 of those groups. So we are going to put brackets around the ammonium and say we have 2 of that group. And then sulfur is a 1, and so that just works like that. So we only put it's only around polyatomic ions that we put brackets if we have more than 1 of it. So if I only have 1 ammonium ion, I don't need brackets. If I have more than 1, I do need to put brackets around that. And I'm just going to clear this. I didn't make myself a separate slide. So the next thing I want to do is give you the formula and work backwards to come up with the name, which that's probably the easier thing to do. And so here, because we're looking at polyatomic cations, I think ammonium is probably the only positive one we have here. So let's do, I'm going to actually do a double polyatomic. So I am going to do NH4OH. And so I already know that this first one is ammonium. We just looked at that. So that's the first part of the name. And then OH, if I look over here, that is another polyatomic called hydroxide. And so the name for that would be ammonium hydroxide. Okay, negative ions, so polyatomic anions, these get treated like nonmetals, except that we do not change the ending on the name. So we keep the polyatomic name for these. So potassium nitrate, potassium is K. It's in group 1, so it's a 1+. Nitrate, when I look that up, the formula and charge for nitrate is, where's nitrate? There we go. NO3 and then a charge of minus. So I have 1 nitrogen, 3 oxygens, and my charge is a 1-. So as we do our crisscross again here, we have 1 and 1 and we don't write the 1. So KNO3 is potassium nitrate. And let's do another one. Let's put this together with multivalent. So let's do iron. Whoops, that's not iron. Iron 3 sulfate. So the 3 tells me that iron has a 3+ charge. Sulfate, when I look it up, is SO4 and 2-. So as I do my crisscross here, iron gets a 2. I only have 1 iron. So even though iron is multivalent, it means I have 2 different options for valences. There's no brackets because it's a monoatomic atom. So it's only made up of one type of element there. SO4, I have 3 of those. So because it's a polyatomic, I need to put brackets around